Let's discuss a question from thermodynamics. This is basically a piston cylinder combination device is given, and uh, it undergoes a constant pressure process. We have a liquid plus vapor mixture. Okay, so you have a liquid plus vapor mixture, and it undergoes a constant pressure process. So let's write down Ts in this diagram. Okay, let's draw a TS dome shape diagram for a pressure. So it's a constant pressure process, whereas 750 joules is transferred to the water. As a result, part of it is of the liquid vaporizes the. Okay, as part of this, the liquid vaporizes. So it's a constant pressure process. Okay, so this is a constant pressure. This is how a constant pressure process look like in a diagram. Now 750 is transferred to the water as a result. Okay, so I mean you are here and some amount of heat is transferred so you get into here. Okay, or you might be here one and you are ending up getting it here. So where you are ending up, you might be having saturated. Uh, you might be at the. It's not even that whether at the start it's a saturated liquid or not. So you might be here. As you supply heat, the temperature increases. You reach up to the saturated temperature for that pressure because pressure is maintained constant, and then some water is vaporized. So 1 to 2 such. So we apply TDS is equal to DH minus VDP, this equation, and it's a constant pressure process, so we need to get so DH dP is 0, so it is DH by T minus 0 because constant pressure process. Now we need to find out, we know the temperature. Okay, heat is transferred to the water as a result of at 300 during a constant pressure process. Okay, so now this problem actually we can only solve assuming that you have the mixture you have it here actually, because I mean the initial state is this, because when you are here to here you cannot solve it because the temperature will change and you don't know. I mean you have to again separately calculate the entropy change for this part and entropy change for this part. So we assume that the start point is here and the second some water has been changed, so temperature remains constant. That is what is the assumption. So the enthalpy change will be, because it's a constant pressure process, in a constant pressure process the heat transferred is nothing but the enthalpy change, right? It's H2 minus H1 for a piston device. Okay, it's H2 minus H1, the heat transferred, because you can write this is again dq is du plus pdv, and you can write du as okay, so this is constant pressure process, so dv. Now what I'm saying is enthalpy is defined as u plus pv. So if you take dh u plus d, if you differentiate on both sides, so pdv plus dpv. Now it's a constant pressure process. Okay, so du plus pdv I can write dh minus vdp, but constant pressure process, so this is 0. So heat transfer is dh, so that is nothing but dq by t. Okay, and so in a process dq, and that even in fact the other way of solving is ds. You have that dq by t is the formula of the entropy for an internally reversible process. All processes are internally reversible, so from this also you can come up with the same thing. Okay, because I started with this equation because there's a standard equation for entropy calculation. So dq is given 750 kilojoules by temperature is 300, so it is 2.5 kilojoules per Kelvin. So 2.5 is the answer, but there is an assumption that the temperature, uh, the temperature at the start, the pressure is such that it is at the saturation. Okay, so I mean it is at the saturation because okay, I think we misread the question. It is liquid plus vapor mixture at the start. So at the start, you're all either here or somewhere here. Okay, so let me just redraw it, because at the start it is given that it's a liquid vapor mixture. So you are somewhere here, and some water has been, the entire water has not been vaporized. Some water has been vaporized. So you are going from here to here. So you are still in that line. So temperature is constant, temperature will be constant, because once the phase change has completed, then only there is a chance temperature will change. As the pressure is maintained constant, the temperature will automatically be constant for a liquid vapor mixture. So you are going from 1 to 2, and therefore so this part holds correctly. So we were thinking that whether it's starting here, so this is wrong, this is exactly correct. Okay, it's changing. You initially you have some liquid water vapor mixture, and then it's some liquid has been vaporized but not completely, so the temperature will not change as long as the pressure is constant, and it's a constant pressure process. So either you can, so we have done in two ways. Either you can use the equation get dH by T. dH we can show that in a constant pressure processor, dq is dH, so we are getting dq by T. Or you start from the definition of entropy, and same way you, the end result is same. So 2.5 kilojoules per Kelvin. Thank you.